past classes like basic of fundamental fundamentals, basic of networking, IPv4 addresses, logics of complaints, and IPv6 address logics also, and how data flowing from one device to another device, the backend process, like due to the TCP/IP protocol, how it functioning, we clearly discussed, and introduction to routers and router internal external components, and types of routers, functions of routers, and how to configure initially router and WAN technologies, WAN connectivity, WAN configuration, and WAN troubleshoot, static routing and subnetting, and dynamic routing about RIP, OSPF single area, OSPF multiple area, and differences between RIP, OSPF, and EHRP, and where we use BGP protocol. Also, we clearly discuss, right? So, do you have any doubts regarding all the topics? You see the list of all the topics regarding these topics. Do you have any doubts? Network fundamentals, in IPv4, in IPv6, TCP/IP, 7 layers, and router components, initial configuration of router, WAN connectivity, WAN configuration, subnetting, routing, dynamic routing, OSPF, single area, multiple area. So, do you have any doubts, guys? I hope everything is right. Okay. Yeah, one day we'll discuss about IPv6 configuration of router, static routing. The same commands, what we have, how we have configured IPv4, same commands, but simply you can say IPv6 address or IPv6 root, destination network ID, destination subnet mask. So wherever you are using IP space address or show IP root or show IP interface brief, show IP IP address. This for IPv4. For IPv6, just add show IPv6 address. Majorly we use IPv4, not IPv6. So IPv6 and interface 3, IPv6 address like this. Just replace with IP into IPv6. That's it. In the real time, mostly we use what? IPv4. For the next generation purpose, we require the knowledge on IPv6 also. Right? So regarding this technically, do you have any doubts? All right. These all topics are clear. Perfect. So we have done about network fundamentals, router connectivity, and routing. Today, let me start with switching. This switching part, network access. What is the major points? What is the major technology we have discussed in routing? Lot of scenarios you have seen, right? Like R1, R2, R3, source destination. So mostly based on this topology and one more topology. Based on this topology, lot of scenarios you have discussed, right? What is the major technology you have discussed in the routing part? Routing is a process of moving IP traffic from one network to another network, right? So when the traffic is moving from one network to another network, is involves the two basic activities. The one is finding best routes. To reach destination, have more than one path. What routing protocols, what exactly routing algorithms will do? Going to find the best routes based upon the different algorithms like distance vector, link state, advanced distance. We have so many protocols are there, right? So based upon the protocol type, algorithm type is going to find the best routes automatically. When best path is being failed, it finds automatically second best path also. So one best path is being found, your traffic is going to forward through these best paths. These are the major activities of routing. Means traffic is going to switching and forwarding, packet switching and packet forwarding. The traffic is going to outside via gateway, via router. But in network access switching classes, completely we are going to learning about LAN. Within a LAN technologies, right? Let me take one small example. Let's consider it is my office building. In office building, the ground floor, the first floor, second floor, like number of floors. So within the office, how the traffic is being maintained. Within the organization, how devices are connected, how to manage it. So this comes under what? LAN technologies. So two or more devices are interconnected in limited area or local area called what? LAN. The LAN technology is the most very important role which is playing the device called what? So one more device is wireless access point. If all devices are connected via wired, we used to connect with this way. If devices are supported for wireless, we used to connect with wireless access point. So within the office, have a devices in the wired or wireless. We use the two devices or what? Switches and wireless access point. So majorly we use switch. You know why? Why? Because compared to guided and unguided, so which can support for reliable communication. Wired and wireless, which is the best? Yes, please. Wired. Why? So wired is a guided media. Wireless is what? Unguided. There is no proper guidance for wireless, right? Maybe signals will come in the different directions. Signals will drop. You move around from somewhere. Signals are dropping, right? We don't have any proper guidance. But if we use a wide guidance, like all the signals has to pass through this wide, have the proper guidance. So there is no chance for data loss, data drop, and we can get very high speed also. So compared to guided and unguided, guided is the best one. So similarly, within your companies also we use mostly. Right? So we are going to discuss more detail about what switch. The LAN technologies. So Ethernet is a most popular physical layer LAN technology. So we have a small introduction about Ethernet, where which university is being developed. Like technology originated by actually University of what? Hawaii University. And later Xerox Corporation has been adopted. We already know about the speed of Ethernet, right? Support for what? Maximum 10 Mbps. Types of Ethernet. Ethernet, fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet. Actually, the long back, the 1970s, IEEE engineers, they have started one project work in LAN. Like within a room, devices, how they can communicate, how they can share the file. or maybe device in a within a floor, how they can communicate, or maybe one floor to another floor, or within a building. Like devices are in a limited area, those devices how to enable communication. So first they have started project on LAN technologies. So for the project, they have defined one code. Standard code is a 802. 802 is a LAN code. IEEE engine is standard code is what? 802. Like under LAN technologies, we have many more technologies. One of the most popular physical layer technology is what? Ethernet. So Ethernet is a LAN technology or WAN technology? Comes under LAN, right? So what is the code of LAN? 802. Like any technology comes under LAN, will start from where? 802 only. So to define the Ethernet, they have used code is 802.3. Use Ethernet. So by using Ethernet from device 1 to device 2, they can transmission the data with how much speed, guys? Say 10 Mbps speed, right? Like after later, again they are working on a how they can improve the speed, how we can two device can communicate more than 10 Mbps. So again they have introduced one more type of Ethernet, which is fast Ethernet. So fast Ethernet also Ethernet technology, right? So what's the code of Ethernet? 802.3 is Ethernet, but is a fast. To define the speed, the use code is U. 802.3 U. Again, when you are working with very high speed applications, like how can support for more than 100 Mbps, have introduced gigabit Ethernet phone. Gigabit Ethernet is also Ethernet family 802.3. To define the speed, the user code is what? A, B, and Z you can use. Okay, 802.3, A, B, and Z. You have a 10 gigabit Ethernet. 802.3 EE. These all are Ethernet family. And as per IEEE standards, the codes, Wi-Fi is a LAN technology or WAN technology? LAN or WAN? LAN. Wireless. Okay, wireless means LAN technology, right? No, it's a LAN technology only. Wi-Fi means a LAN technology. Within a LAN. If you have a Wi-Fi device, so how much range can support it? 100 kilometers can support? 10 kilometers can support? No. 1 kilometer can support? No. It's a limited area, like meters. Depends upon the device to device also, like 50 meters, 10 meters. Frequency ranges will depends. So means within a limited area only means a LAN technology. So Wi-Fi is also LAN means the code is what? 802 dot. Dot 3 is a physical port, Ethernet port. Dot 11 is a wireless. 802.11. The speed frequency is A, W, Z, something you have it. Think of it. Ethernet, speed, and IEEE standards. Ethernet speed is 10 Mbps. Fast Ethernet 100 Mbps. Gigabit Ethernet 1000 Mbps or 1 Gbps. 10 gigabit Ethernet 10,000 Mbps or 10 Gbps. And IEEE standards. for Ethernet, 802.3 for fast Ethernet, 802.3 U for gigabit Ethernet, 802.3 AB and Z for 10 gig, 802.3 AE. So just introduction of Ethernet port. Now let me discuss majorly very important point about switching. Hello, can you hear me? My voice is clear. Right. So just switch. Now we'll clearly discuss about switch functions, how switch is functioning. So we already discussed about router, right? Router functions 4 points. Best selection, inter-network communication, packet switching, packet forwarding. The router maintains the routing table. Once traffic is come to router, what router will do? Will check the routing table. If destination IP address is already updated in the routing table, packet switching and packet forwarding. If destination information is not in the routing table, what router will do? Drop in the top. This is a function of router. But now I'll say about switch. How switch is functioning now? So switch port numbers. Consider port number 1, port number 2, port number 3, port number 4, 5, 6, 7. Like it's a 24 port switch. For port number 1, have one device is connected. Device 1. Port number 2, device 2 is connected. For port number 3, port number 4. Like 6 computers are connected. Let's consider. For every computer, we have unique MAC address, right? So what is the command to check MAC address? Get MAC, right? So for every device, we have a unique MAC address. Let's say first PC MAC address is A1. Second computer MAC address is A2. PC3 MAC address is B1. It's B2. It's C1. It's a C2. The unique MAC address. Now to enable communication between all those devices, we have to assign IP address. It can be class A or class B or class C, right? From class A, class B, class C, also within the LAN, we have to make use private IP address or public IP addresses. Private IP address. It can be class A private IP or class B private IP or class C private IP. So my example, I'm using class A private IP address. Can you tell me guys, class A private IP address example? Class A private IP example. Right. 10 dot network. Like any IP starting with 10 is a private IP, right? Okay, for first computer, PC1, let me assign 10 dot 0 dot 0 dot 10. For PC2, 10 dot 0 0 20, 10 30, 10 40, 10.50 and 10.60. Now all devices IPs assigned. Now devices are ready to communicate. They can communicate now, right? So this communication process we have to understand very clearly. Is the main point now here. Like how switch is functioning means switch is intelligent device is maintained one table called MAC table. MAC. We call it is what? MAC address table. MAC address table. Like what is the information inside the MAC table is port numbers. Your switch port numbers. If a switch is a 12 ports and 12 port numbers will be there. If a switch is a 24 ports, 24 port numbers. Your switch is a 48 ports, 48 port numbers. Along with your PC MAC address, in device MAC addresses. Port number and MAC address. Which is very important point here it is guys. By default your MAC table is empty. MAC table is what? Empty. Even your in device is connected, but default your MAC table is what? Empty. So let's see how they are communicating means. A small example. First computer want to trying to communicate with a last computer. I repeat once again. Like PC1 is trying to communicate with PC6. So here, which one is a source device and which one is a destination device? PC1 is a source and PC6 is a destination, right? So from PC1, traffic, your traffic is being generated. Here, source IP address. What will be the source IP address? Source IP address is 10.0.0.10 is the source IP. So what is the destination IP address? Destination IP address is 10.0.0.60. Okay, good. Now what is the source MAC address? Source MAC address is A1. The main question is here, what is destination MAC address? What will be the destination MAC address, guys? Right, how we can say destination MAC address is C2? So how we can say destination MAC address is C2? Yeah, network diagram I have clearly mentioned PC6 MAC address is C2. That's the reason you can able to tell, right? But you tell me, guys, like from your laptop, can you come to know my computer MAC address? So from your devices, you are trying to communicate to my laptop. So now you tell me, Ram. So what is my computer MAC address? My computer MAC address. I'm asking about my PC MAC address. You don't know, right? Like initially, we don't know about destination MAC address. Destination MAC address is unknown. So we don't know about destination MAC address. I have my PC in a first floor, and I'm trying to communicate with a one more device in the second floor. How I can come to know like destination MAC address? I don't know, right? So this is the main point here. So initially, destination MAC address is what? Unknown. What switch is doing is in IPv4 address, the range is 0.0.0.0 to 255 dot 255 dot 255 dot 255 is a complete IPv4 address range, right? Now what about MAC address range? MAC address is a hexadecimal digits, hexadecimal numbers. The combination of what? 0 to 9 and A2. Yeah. MAC address represent 12 hexadecimal digits. The highest MAC address is FF, FF, FF. Like all FF. is a highest MAC address. Is the last highest IPv4 address. The last IPv4 address we call broadcast IP address. Similarly, the last MAC address we call it is a broadcast IP address. Sorry, broadcast MAC address. So all 255.255.255 is what? Broadcast IP address. All FFF is a broadcast MAC address. So when destination is unknown, the destination MAC address, automatically your broadcast MAC address will be stored here. Now the destination MAC address is what? Broadcast. So this broadcast MAC address is being updated by using one protocol which is already working in your switch. That protocol is a ARP, Address Resolution Protocol. So what ARP is asking is, hello destination. My destination is 10.60. Hello 10.60 computer. I need your MAC address. So just give me your MAC address. I want to communicate with you. I don't know your MAC address. So please give me your MAC address. It's in the request. ARP request. So ARP request for what? For what purpose, guys? ARP request for what purpose? To get the destination MAC address. So ARP request is sending by using which MAC address? Broadcast MAC address. So this all information is being generated. Source IP, destination IP, source MAC address, and destination MAC address is broadcast MAC address. So this broadcast MAC address is being updated by using which protocol is a ARP. ARP will come in the picture. So this is complete information we call what? Source IP, destination IP, source MAC, destination MAC. This is a frame is being generated. So in the short form, we can say traffic IP packets. So frames are come to switch. What switch is doing is not routing protocol, address resolution protocol. Okay. Now once traffic is being received to switch, what switch is doing is very first function of switch. I repeat once again. So what first function, first action of switch is doing is, so from which device traffic is being generating, so that computer MAC address is going to learning. The short form I can say learning source MAC address and will be updated in the MAC table. Now, as per this example, the traffic is being generated from which computer? First PC, right? So what is the first computer MAC address? A1. Your first computer is connected to the switch which port number? Port number 1. So port number 1 MAC address A1 is being updated in your MAC table. This is the first action. Like always, switch will do what? When traffic is coming from the PC, learning source MAC address. If traffic is coming from B2, B2 MAC address is being updated. If traffic is coming from A2, A2 MAC address is updated. If traffic is coming from my mobile MAC address is being updated. If traffic is coming from your laptop MAC address is being updated. From which computer traffic is being generated, the computer traffic is being updated. Okay, like after learning MAC address, now what it is doing is it look for destination. Okay, now where and to send it? What was the destination MAC address? What is the destination MAC address, guys? Now destination MAC address is a broadcast. So what is broadcast and what is unicast? So broadcast are, you can tell me like it's a flooding actually. Which will do what? Flooding. Mostly same, both are same. So flooding and broadcast difference is flooding means sending traffic from one to all, and broadcast also one to all. The difference is broadcast and flooding is one to all except source. Broadcast means included source hours. These are different. So Broadcast means what? One to all, including sources. Flooding is what? One to all except mostly similar, right? So right away, I'm calling it as what? Broadcast. But actually, switch will do what? Flooding. Technically, I'm calling it as what? Okay. Then what is a unicast mean? Sending from one device to one device, one to one communication. Source and destination. Now source address is being learning updated. Now what it is doing is look for what destination MAC address. Now destination MAC address is a broadcast. So what it is doing is, so this packet, this information will send to port number 2, port number 3, port number 4, PC5, PC6. Like how many devices in the network, like is sending the information to all devices. So based upon this example, how many devices are connected? 6 computers are connected. Like one device is sending the information, remaining 5 devices are receiving, right? But in the real time, like maybe switch 1 is connected to one more switch, like one more switch is connected, like one more switch is connected, like any one device is connected, remaining, let's say 90 devices, like 90 devices can receive the broadcast. So this is happening in LAN. Like after broadcasting, now 6 pieces are receiving the broadcast. Receiving the broadcast, what PC2 is doing is, so this packet is being opened. Now what PC will do, we'll check the source IP and destination IP. So source, you're coming from 10.10, okay, what do you want? What is your destination? Your destination is 10.60, but sorry, I'm not your destination. My PC IP address is 10.20, so I can't reply, I'm dropping your request. So 10.20 is being dropped. Now PC3 also received, right? What PC3 is doing is open the package. Like open it, okay, you're coming from 10.10, okay, no problem, what do you need? So my destination is 10.60, okay, your destination is 10.60, so sorry, my IP address is 10.30, I'm not your destination, I don't want you to reply, it's going to drop the traffic. Like all pings can drop the traffic, now which piece is the reply? 10.60. So 10.60 also received. What is open the packet? Okay, you're coming from 10.10. So what do you need? I'm my destination is 10.60. Yeah, I am your destination. So now you tell me what you need. Asking ARP request. Yes, 10.60. I need your MAC address. Please give me your MAC address. I want to communicate to you. Okay, you need my MAC address. Okay, let's take my MAC address. Now 10.60 is giving the reply. Now source IP is 10.60. Destination IP is 10.10. Source MAC address is what? C2. Destination MAC address is what? ARP reply. Destination is a ARP reply. ARP reply for which computer? A1. So this is being generated. So this traffic will come to switch. Now what switch will do, guys? Now what's the action of switch? When traffic is reaching the switch, what switch is doing is going to learning source MAC address. Now the source MAC address C2. Which port number is connected? Port number 6. So port number 6 C2 is being updated. Like after learning source MAC address, you look for destination MAC address. Now what is the destination MAC address? Destination MAC address is a ARP reply. ARP reply to which MAC address? A1. Now A1 is already updated, right? So again, do you want to broadcast it now? No need. Why? Because already the destination MAC address is updated. So what PC is doing is switch is doing is it's sent directly to A1 computer. So this communication we call what? Unicast. Finally, what I'm telling is switch can support for unicast and broadcast. But you tell me, guys, when switch will do broadcast and when switch will do unicast? will when MAC address is updated. Okay, what type of communication? Request, broadcast, reply, unicast. Unicast, source and destination is known. Perfect, Mustafa. Right, all right. So let me explain clearly when switch will do unicast and when switch will do broadcast. And very simple. Logic is if destination MAC address, if he is present, if he is updated in MAC table, unicast. If destination MAC address if is not in the MAC table, broadcast. So when switch will doing the broadcast, which product will come in the picture? ERP will come in the picture and he's sending the what? Is adding a all FFF broadcast MAC address, request and reply. A simple example in my office building, from my computer, I'm trying to communicate with my office printer. So office printer and my PC both are connected to switch, right? So when I'm trying to access a printer, if printer MAC address is not in the MAC table, what switch will do? Unicast or broadcast? Broadcast. Now, broadcast to how many ports? Broadcast to how many devices is the main point. So actually, scenario is a like one user, one employee is trying to accept print. If printer MAC address is not in the MAC table, what switch is doing is for the switch, how many switches are connected and how many ports are connected, how many devices are connected, like all devices and in the broadcast. So these devices can be 10 devices or 100 devices, 1000 devices. What switch is doing is sending broadcast remaining all devices. Right? Example, if your PC, like my printer MAC address is a P1 printer MAC address, let's say D1 is a printer MAC address. If it's already updated, D1 is updated. Now, what type of communication happened, guys, here? Broadcast or unicast? Unicast. So, like very happily, user one directly will communicate to print and you can get print access. No, no disturbance to others, right? So switch will depends always what based upon what MAC table. Like how router will depends upon the routing table. Same like a switch also will depends upon based upon what MAC table. Now from my office computer, I'm trying to communicate with my organization server. Like it's a FTP server. I'm trying to access FTP server. So source is my PC, destination FTP server. Traffic is being generated, which is look for the destination MAC address. If FTP server MAC table, if is the present in the MAC table, it's in the unicast. If FTP server MAC address is not in the MAC table, what it will do? Broadcast. The main point is broadcast to how many ports is a very important. So broadcast to all the ports, rest of the remaining, all the switches, all the ports. Here is a switch one, your PC and your server in the same switch. Broadcast to your 24 PCs only, 24 ports only. The switch is connected to one more switch, one more switch, one more switch, one more switch. What switch will do? Broadcast to all the ports, all switches. The broadcast size been increased. Right. The main point about switch function. Switch will do for unicast and broadcast. Whatever a switch can support for communication is half duplex. It can support. Same time, it can support for full duplex also. Unicast and broadcast. Right? Both can support. When ARP will come in the picture, when switch is doing broadcast, ARP will come in the picture by using broadcast MAC address is what? RFF. Okay, next point is here. Now PC2, port number 2, port number 3, port number 4, port number 5. Port number 2 MAC address is A2. Port number 3 MAC address is B1. Port number 4 MAC address is B2. Port number 5 MAC address is C1. Now 6 devices MAC table is updated. Now you tell me guys, in my switch, what type of communication happens? Unicast or broadcast? Unicast. Very good. Secure communication. Okay. Now after some time, so PC3 is not in use. So PC3 is in a idle. So from PC3, there is no request is not generating. So when the PC is idle, like is not generating any request, what it is doing is, so this PC3 B1 MAC address information can hold up to 300 seconds. Okay, like up to 300 seconds if there is no request from PC3. So what switch is doing is automatically your B1 MAC table, your B1 MAC address is being flushed. So after 300 seconds, your MAC address has been removed. Now after 300 seconds, PC4 user is trying to communicate with PC3. Now tell me guys, what type of communication starts? Unicast or broadcast? How many ports? Broadcast to how many ports? Broadcast to, like due to the main point is here, like not only all devices, any one device is not in the use in your network. Up to 300 seconds, if any device not in the user network, what switch is doing is again sending the broadcast to all the devices in the network. So mostly, what switch will do? Broadcast. So as a network engineer, our job one, a network administrators, our roles and responsibilities. So these broadcasts we need to minimize. These broadcasts we need to reduce. If we don't reduce the broadcast, we cannot provide the proper service in the LAN users. So we cannot provide the proper security for your LAN users. We cannot provide the proper speed, proper performance for the LAN users. Like how we can minimize the broadcast, we have a separate concept. We'll discuss clearly now. There is a 24 ports. Port number 1, port number 2, 3, 4, 5, 6, 7 ports. Number of devices are connected here. Now, first PC is trying to communicate with the last PC. Default MAC table is empty. Now, what type of communication? Broadcast. By using which protocol? ARP. Now, broadcast how many ports? All the whole switch, right? And they're all 24 ports. So, main switch is a one broadcast domain. The complete 24 ports is belongs to one group, one logical group. right? The logical group we call what? Broadcast domain. Domain is a group. What type of domain? Broadcast domain. So switch is a single broadcast domain. A single broadcast domain. Have a one more 24 port switch is a switch A, it is a switch B name. Switch B also 24 ports is also one another single broadcast domain. Have a one more switch. The switch name is a C, is also 24 ports, is a one more another broadcast domain. Like in my network diagram here in this topology, total how many number of broadcast domains are available? Three different broadcasts. Switch A, switch B, and C. Three broadcast domains, right? Then what I'm doing is I'm going to connect one cross cable from switch A to switch B. So once I connect a cable from switch A to switch B, now you tell me guys, total how many broadcast domains are available now? Two. Which one? A and B belongs to one domain and another C is what? Different broadcast domain. So in PC1, I mean switch A, PC1 is trying to communicate with PC2. If destination MAC address is empty, what switch A is doing is broadcast to 2, 3, 4, 24. The same broadcast packet will send to switch B port number 24. 24 will broadcast to enter the switch. Now here, 48 ports is a broadcast domain size. Size of the broadcast domain is what? 48. Number of broadcast domains are PC switch A and B is 1 and C is number. Once I connect from port number 23 to 24, like switch B to switch C, cross cable is connected. Now you tell me total how many broadcast domains are available in this diagram. Now total how many number of broadcast domains? 72 ports is the size of the broadcast. But I'm asking broadcast domains numbers. Number of broadcast domains are what? Only one broadcast domain. So physically there are three switches, but logically, like all three switches belongs to one domain, which is broadcast domain. Like out of three switches from any device, any broadcast is being started, the broadcast is going to affecting to the whole 72 ports. Like if we connect one more switch to the this link, this network topology, if I connect one more switch, in broadcast domain size been increased, right? So as much you are increase the line size, we are increasing domain size, broadcast domain size. So here only my example is switch A and B and C, three switches. But once you go for the real time example, if you take any university, in one university, like how many blocks, how many departments, how many end user end devices, how many switches are connected? Like all are interlinked. Thousands of devices, hundreds of switches, all are interconnected. From hundreds of switches, any one device can generate. Remaining all switches are going to affect the broadcast. Okay. Like if you go for any like a IT companies, very large number of devices broadcast. Go for any pharma companies, like very huge equipment, number of devices broadcast happen. As the network engineers, our roles and responsibilities, we need to manage this broadcast. Okay, guys? So this is a function of switch. Now let's we see clearly discuss about types of switch. The types of switches are majorly have a two types. One is a manageable switch and unmanageable switch. Manageable and unmanageable. The name itself is telling is what we can manage, and one more is what unmanaged. So what we can manage, what we cannot manage, we'll see clearly. Here I have a two scenarios here. Scenario one, first scenario, this one office building. Office name is ABC. It is from Amirpet. Maybe Amirpet in Hyderabad, Banjara Hill. I have one more office. Office name is XYZ. Office XYZ in Jubilee. Now network engineer. I'm a network engineer. My office is Zoom Technology in Amirpet. I'm here. I used to work from Kerala, right? So Zoom Technology has a customer. Clients actually we have. Even I used to work on police department, which is communication department, and banking sectors. We have the clients. For this example, we have Zoom Technology has two customers. Customer one is ABC. Customer two is XY. Now, what is the main scenario here? Is a office ABC is maintained complete switch one and two, three, four switches. Like all switches, office ABC is maintained manageable switches. Office XYZ using like total switch one and two, three, four switches are unmanageable switches. So now clearly discuss what is the performance, network performance of Office ABC performance and Office XYZ performance. Let me see now. So first you tell me guys in Office ABC total number of broadcast domains. Till now there is no interlink between a 1, 2, 3, 4 switches. We have the four departments. So in Office ABC building, how many number of broadcast domains are available? Four domains. 1, 2, 3, 4, right? I connected a switch 1 to switch 2. So how many broadcast domains? 3. Right. Switch 2 and 3 is connected. Now 2. Now 3 and 4 is also connected, interlinked. Now how many broadcast domains? 1. What is the size of broadcast domain? If each switch is a 24 port. 96. Okay. So is all switches maintains the MAC table. By default, MAC table is what guys? Empty. Even the manageable switch also, if any one PC will generate the broadcast, the broadcast is going to sending to how many ports here? 95 ports. Except one, 95 ports. But what is the major difference between manageable switch and unmanageable switches? The first point is if it is a manageable switch, so this broadcast domain size we can reduce, we can minimize. Like I can tell to the switch, like switch, like don't broadcast to all 95 ports. Now broadcast only for 3 ports. Now broadcast only for 4 ports. Now broadcast only for 2 ports. Or broadcast only for my department only. Or broadcast only for my room only. Like we can configure that. We can tell that like this. We can manage like this. So simply you can say we can limit the broadcast size. We can reduce the broadcast domain in which type of switches, guys? In manageable switch or unmanageable switches? In manageable switches only is possible. So first difference is keep in mind Surely you can ask the questions in interview. So if it's a manageable space, we can minimize the broadcast domain. We can reduce the broadcast. But what about in the switch Office ABC? Like Office ABC, if all devices are interlinked, always 96 ports will do what? Broadcast. Not reduce that. We cannot minimize that. So which network performance is the best now? Manageable switch or unmanageable switch? Now which network is secure now? Manageable Office ABC or Office XYZ? So Office ABC Office is a network performance is a good, like good performance and secure network. XYZ is maintained unmanageable. Broadcast happen, unwanted traffic is coming to all the ports. It is not secure also. This is the first difference between manageable and unmanageable. The second point number two is we are providing internet connection. Let's say from Act Fiber, we're providing internet for the two customers. One link for customer ABC, one more link for customer XYZ. And now my local server, office server is connected to switch to any one of the ports. This is a FTP server. The switch 2 itself, you have one more server is connected. This is a mail server. In Office ABC, now what are the resources available now? Tell me, guys. What resources are available? Internet access is there, FTP resource, and mail server resource is available, right? These resources can be accessed by all 96 users. Like all 96 ports can be utilized. FTP servers, mail servers, and internet. Everyone can utilize it now. But as a network administrator, what we do means, so I don't want to provide like how many users in my LAN, all users should not access my internet. Like all users should not access my file server. Like all users should not access my mail server. So we need to control some users. Only limited users only have to access internet. Only limited PCs only have to access a mail server. Only limited users only can access the FTP server. We can control them. Like how can access? How can control that? So to control the network access is possible with the help of which switches is a again manageable switches. Actually, Act Fiber cable is connected to router to switch. But just for example, I'm taking the cable from Act Fiber to switch. Okay, guys. Right. See, the point is here. The point is here actually is what? What are the resources are available? Mail server, file server, internet is all the resources. It is already connected. Now all users can access it. If all the users are accessing it, our network speed will be slow. Maybe they can be misused. What we're doing means only limited. We can control the traffic, but is not possible in unmanageable switch. So once ISP cable is connected to in the switch port, all 96 ports from any port, if you connect your Ethernet cable, you can get internet. You cannot control that internet access. You want to control only one thing. Remove the cable from switch A and 2. No access. No internet access. At the same time, what? Switch A users and switch B users also no communication, right? So communication if you enable cable. If you enable cable, all device can access internet again. The problem with unmanageable switch. Not control the network traffic. The two major points, technical points we have discussed. Point number one is you can minimize the broadcast and you can provide the good performance in the network and you can provide security also. And point number two is what? You can control network traffic. Right? Okay. So two major points. Point number one is what we can minimize the broadcast domain size, and point number two is network access control, and point number three is a network engineer. I'm a network engineer. I'm working on which area? Amit. The organization is what? I got a mail from Office ABC. The mail is what we have some network issues in my Office ABC. So try to solve it. Then what network engineer is doing means okay, no problem. So what network is doing is they can log in remotely. We can take remote login switches. I can log in the switches. I can find out the problem. What is happening exactly? Any configuration or any IP, like any configurations is I can try to find out the problem. So why? Because manageable switches, we can configure telnet process, telnet access. We can enable telnet access. We can assign the IP address to log in it. We can support for remote logins. Configuration can be made. The second example is I got a one more mail from XYZ. The mail was so even we have some network issues in Office XYZ. So what network engineer has to do? From Amirpet, physically, manually, we need to go for Jubilee Hills office and check in switch A or B or C or D which switch is the problem, connectivity problem or port problem we have to find out. You know why? Why? Because unmanageable switches cannot support for remote access, cannot support for configuration. You just purchase the switch and you can plug in and play it, like plug and play type. So these are the major differences between manageable switch and unmanageable switch. Okay. Then how can find out which is a manageable and which is unmanageable switch? Physically, how we can find out? Is there any printed? Is it? Is it manageable? Is unmanageable? No, there is no printing like that actually. The manageable switch, unmanageable switch, difference is what? In the manageable switch, we can configure it, right? So to configure the switch or to configure router initially by using which port you can configure? Which port you can configure initially? Console port, right? So by seeing the console port, we can find out which is a manageable switch, which is a unmanageable switch. Switch with console port is a manageable switch. Switch without console port is an unmanageable switch. Can be any vendor, even D-Link router, when any vendor, HP router, HP switch, any switches. If there is no console port, if it's unmanageable, if any console port is there, it's what? Manageable switch. So there are the difference between manageable switch and unmanageable switch. Clear, guys? Are getting the point? Manageable switch, you can manage the user traffic. Configuration can be made. IP address can be assigned. It has console port. Unmanageable switch, we cannot configure. We cannot manage the user traffic. We cannot assign the IP address. You don't have any console port. Clear? Let me give you some notes on manageable, unmanageable. the 2 points here: manageable switch and unmanageable switches, right? On a manageable switch, an IP address can be assigned and configurations can be made. It has a console port. Unmanageable switches, configurations cannot be made. IP address cannot be assigned, and there is no console port. Clear, guys? Right. Yeah. When we have discussed about routers, do you remember, guys, router categories, branch routers, edge routers, network edge routers, ISP routers? Like how we can identify which routers are branch routers, which one is the network edge routers, which one is ISP routers? Similarly, same like in the switches, also we have some hierarchy design is it? Like access layer switches, distribution layer switches, and core switches. Three categories, three hierarchical design: access layer, distribution layer, and core layer. So generally, switch will comes under which layer of the OSI, guys? Which layer? Switch will works in which layer? Switches are layer 2 devices. Which devices are layer 3 devices? Router. The main point is here, access layer switch is a layer 2 switch. Access layer switch is what? Layer 2 we can say. And which are distribution layer switch? Layer 2 and layer 3. L2 and L3 both. With the core layer also, it comes under L2 and L3. Multi-layer switch. Only access layer switch is a layer 2 switch. So distribution switch and core switch. So these switches can act like a router also. So in a company, you have a distribution switch, router is not required. So distribution layer switch can do the both, even the acting like a switch as well as what router. We can configure RIP here, you can configure OSP here, you can configure static routing. So this switch can be maintain the routing table, switching, forwarding, internet communication, best path selection. Like all about router functions can do this device also, which is distribution layer switch. The short form you can say layer 3 switch. So which are the layer 3 switches? Distribution layer switch and core switches are what? Layer 3 switches. The layer 2, the both are what? Layer 3. The small companies, the small organizations generally, they don't maintain the routers. So what they will do, they'll purchase one distribution switch. They'll purchase what? One distribution switch is layer 3 switch. From layer 3 switch, L2 switch, again L2 switch, again L2 switch, they can extend the LAN. Now, which is a layer 3 switch, this switch can act like what? Router as well as switch. So, for this switch, we can connect what? ISP cable, ISP cables. Like these are very large enterprise networks. Then we have dedicatedly routers, dedicatedly switches. So by seeing the console port, we can identify which is a manageable and which is unmanageable switch. But by seeing the switch, how we can identify which is layer 2 switch, which is a layer 3 switch. Depends upon the series, model numbers. Access layer switch series, distribution layer switch series, and core layer switch series. You can copy. Layer 3 switches don't have any serial ports. Serial ports for routers only. Layer 3 switches all are Ethernet ports. Okay. Yeah, Pradeep, actually, ISP cable which is connected to your Ethernet port. Yeah, serial ports are outdated, but still some companies are using some laser lines. So for laser lines, serial ports we use. 802 dot. Are you asking a question? AF. These PoE switches, power over Ethernet ports. Yeah, we have a separate model numbers for separate designs for PoE switches. It is released by Cisco. So these are our normal Ethernet ports. 2950 to 960. Now let me continue with how to configure. In Cisco package the software, we have 2950, 2960, even 3560 is available. Let me take one 2960 switch. Have a 24 ports. The switch, let me connect some end user devices. I'm using here 7 devices, for example. Yeah, good question actually, Nihas. No need. So if you know how to configure Cisco routers and Cisco switches, so again we don't require any special, again the special separate knowledge on other vendors. Like what are the protocols have discussed? Like OSPF, RIP, static routing, IPv4 logic. Everything is same for all devices. So when we are discussing about OSPF, we discuss very important one point is what is a open standard. It can support what? So what is the mechanism of hello packets? Everything is open standard, right? All the same thing. But only difference is a small difference is commands. Example in we are hands-on practicing, we are learning about what Cisco switches and Cisco routers, right? In Cisco switches from user mode, privilege mode, global configuration mode, enable, show commands, the same like a other vendors are, they use in the different terminology. In the short form, you can say, yeah, in iOS we are using Cisco. For other vendors are they have their own iOS, own operating system. iOS only for Cisco. The Cisco we use what? Show IP address, show password, show interface, show version. To go for HP, they use display, display IP address, display password, display IP, display routers, like this. Terminology is different, commands only difference, but everything is what same, technically same. Okay. This devices, let me connect it. Cable from PC1 to switch and PC2 switch 4 2, 4 3, 4 5, 4 6, 7. Assign IP address to PC1 192.168 1.10. The second computer 1.20, 1.30. So how we have configured router? Same configuration for switch also. Router operating system is iOS. Switch operating system is also iOS. Both are same. Router, what are the modes we have discussed? Like user mode, privilege mode, global configuration mode. Same modes in the switch too. Here you can see switch greater than symbol is a user mode. Enable. Switch privilege mode hash to command. Show command the same for switches router. Same like a router. So IP interface brief, show version, show running config, show startup config, internal components. Everything is same. iOS version is 12.2. Here, C2960, 24 ports. 24 ports are each port is what? Fast Ethernet ports, and additionally, 2 gigabit ports also are available here. And if we go with the show running configuration, by default, host name of switch is what switch? Host name is not yet configured. 4, 5, 6, like all 24 ports plus additionally 2 gigabit ports for uplinks. Let me configure switch configuration mode. Host name. My example is switch A. Line console 0. Password zoom login line BTY 024. Password zoom login. What are the commands we have executed in router? Same command. But one a small difference between router and switch configuration. Router LAN port is a fast Ethernet and number is 0. So, like how we can assign IP address to router? What was the command? Tell me, guys. How to assign IP address to router? What is the command? Yeah, right. Interface fast Ethernet 0/0. In interface mode, IP space, address space, some IP address. Example 10.0.0.1 and 255.0.0.0. And then the port is if it's a shutdown, then you can use command is what? No shutdown. If port if it already is up, then no shutdown command is required. No need. If port is shut down by default, then you can use what? No shutdown, right? This is the command. Then now you tell me, guys, what is the command to assign IP address to switch? Have a port number 1, 2, 3, 4, 5, 6, 24th port is my switch. And what was the command to assign IP address to switch? The router port have a fast Ethernet 0/0. They can use interface FE 0/0 as so on IP address and no shutdown. What about switch? Interface fast Ethernet 0/24. Okay. So if you assign IP address to fast Ethernet 24, now port number 24 only can access. What about remaining ports? This is the point here. How to assign IP address to switch means switch is nothing but LAN. The switch internally maintains one more LAN we call VLAN, virtual LAN. By default, you have VLAN 1. It's there, VLAN number 1. Switch ports, how many ports is this? 24 ports, right? So port 1, port 2, port 3, 4, 5, 6, 7, like all 24 ports in the part of VLAN 1, in the member of VLAN 1. So instead of assigning IP address to port number 24 or port number 6 or port number 1, if you assign IP address to VLAN 1, then how many ports we can access? All 24 ports we can access, right? So VLAN 1 IP address is a switch IP address. So to manage the, like in before topic, difference between manageable switch, unmanageable switch, or what? We can minimize the broadcast, we can control the network access, we can assign IP address, we can configure. These all that happen, based upon VLANs. So to manage the manageable space, to manage the VLANs, to manage the broadcast, to control the network access, all those things will be happen based on what? VLAN only. So from today onwards, we are going to learning about virtual switches, virtual LANs. So by default, VLAN 1, all the ports in the member of what? VLAN 1. So VLAN 1 IP address is switch IP address. Command is interface VLAN 1. In interface mode, you can use command is what? So normal IP space address space and no shutdown. When you can see here, show running configuration, the last one, interface VLAN 1, no IP address, and the state is what? Shutdown. Interface VLAN number 1, IP space address 192.168. One dot some example. My example is 1.50. 255, 255, 25.0. No shutdown. See, 1.50 have assigned and I got one log message. You know what is the log message? Duplicate address. Duplicate address is being assigned. So in my network, out of 7 computers, 1.50 already one PC is being assigned. Which PC? 0016373BEE6. MAC address computer is assigned running with what? 1.50 IP address. Let me change it. 1.1 I can use. Accept. So running configuration. Interface VLAN 1 IP address. And switch can support for what type of communication? It can support for half duplex and full duplex. Let me show you how to configure the switch port to speed and how to set it. Interface fast Ethernet 0/1 port number 1. For port number 1, duplex use command is a half. Now port number 1 is being enabled. What type of communication, guys? Half duplex only. Duplex full. Now port number 1 is configured the what is the command? What is the duplex now? Full duplex is working. Duplex is a auto negotiation based upon other device. It can be supported. Three commands. Duplex half, duplex full duplex, and duplex auto. Right. Not only setting the duplex, we can set the speed also. Speed, FE, fast Ethernet. If it's a fast Ethernet, how much speed it can support? 100 Mbps, right? If I configure speed is a 10, the port number 11 can support only 10 Mbps. The speed space 100 can support for 100 Mbps. Speed is auto negotiation based upon the other end device. It can be support for what? Auto negotiation. Show MAC address table. As we have discussed, by default MAC table is what? Empty. Even if I type the show MAC address table, your MAC table is empty. There is no MAC information is not updated, right? Now when MAC table is empty, now PC1 want to communicate with PC2. What type of communication happens in the switch now? Broadcast or unicast? Broadcast. Broadcast to how many ports? So PC2 can receive, PC3, PC4, PC5, PC6, PC7, like all device can receive, right? So here I have one question here. Can you tell me, guys, PC number 4, this computer and the switch, which port number is connected? Okay. Okay. Let me do one thing. I'm confused. Jumping. So before there are sequences, right? Then you are telling directly 4. Now you tell me, guys. So this PC and the switch, which port number is connected? This PC. By display the values, like everyone can tell, right? In real time, we don't have any display. The Cisco packet tracer software, we have option is there. Port numbers, which port numbers is correct. In the real time, what? Like your PC, you are working some in company. Yeah, this is your computer, and which port is connected? Your printer, which port is connected? Like your, like how we can come to know? How we can tell PC which port number is connected? Go to switch. Okay. Using command. Label is made. No labels. Real time, no labels. Like patch is the labeling is there. The patch panel label is there, but switch ports we don't have any label, right? So running configuration. The running configuration we don't have any information. Okay, as you tell, let me use show run config. See which port is connected. So we have discussed a lot of times. Perfect. Use MAC. The MAC address table, what information will be there, guys, here? Port numbers as well as what? MAC address. If you know your PC MAC address, then you can come to know your port number also, right? If you know your PC MAC address, now log into Switch and open the MAC table, you can get your port number. So first let me check this computer MAC address. So see if you keep cursor in the PC, let me keep the cursor in the PC now. The right side last, you can see MAC address, the last 4 digits. Yeah, let me explain the Pradeep. Present, there is no MAC address. If you keep the PC, B 3B85, right? 3B85. Okay. But the thing is, present what? MAC table is what? So MAC table. MAC table is empty. Even we don't get information. Then how we can come to know this PC which port number is connected means? So we need to generate some traffic. Any traffic can be any traffic. Dummy traffic have to generate, like ping traffic, telnet traffic. Any traffic we generate from this PC. So it means that some traffic is being generating here. We'll come to switch. What switch will do first action is learning source MAC address. Is updating the MAC table, right? Not broadcast. Before broadcast, what switch will do? From which computer traffic is being generated, that computer MAC table is being updated. Yeah, source MAC address is updated. So how we can come to know your PC which port number is connected means before login to switch from your PC we need to generate some traffic. Let me generate some traffic. I'm using here ping to my neighbor PC 192.168 from 1.20 something. So some ping traffic is being generated. Now if you log into switch and open the MAC table, show MAC 3B85, your port number 4. Okay, even if I confused, also the same port number is connected. Port number 4 is connected, right? Okay. So technically, how we can get the information means based upon what? MAC table. No. Actually, my lucky number is 3. Maybe in our participants, anyone. So like we can get MAC table in the. Yeah, switch has a broadcast. A broadcast is already done. No, it will not update like that. So broadcast receive this all the devices, and the device is going to drop the traffic. From where which PC broadcast is being generated, that PC only updated. Let me do one thing. Let me ping from all computers. 1, 2, 3, 4, 5, 6. Now if you open the MAC table, all MACs are being updated. So let me check with one command. MAC search. Don't think so it is working or not. Show MAC address. Hyphen table space address space and your MAC address. If you paste your MAC address directly, you can get it's not working. Generally, if you use this command in the switches, the physical switches, MAC search, show MAC table, address space your MAC address, then directly can get the port number. So here, present example, we have 6 pieces only. We can easily find out BS 3B85, yeah, like a filter. In the real time, what we have, like a very big list of the MAC address, right? Like we need to search one by one. Instead of that, you can directly can use address space and your MAC address command, then directly can filter it. So MAC address, like even async command is not working. ARP VLAN 1, your MAC address. Here it shows the A's actually means how many seconds the whole information in the MAC table. 30, we have discussed about what 300 seconds, right? Of the commands. Right, your task is today you try to design this topology. Take one 2960 switch and connect 7 computers for each switch. And take one more switch. 1, 2, 3, 5, 6, 7 devices. Connect the cables in sequence order. 1, 2, 3, 4, 5, 6, 7. Like design the two topologies like one and two setups. So based on this scenario, tomorrow our topic will be continued. So what is the main topic of tomorrow is manageable space and unmanageable space. Difference is what? Manageable space, we can minimize the broadcast, right? How to minimize the broadcast? How to manage the network? You can manage it. What we can manage, we can control the traffic. How to control it? Like by how to create the virtual LANs. So these are all the topics. The next class will be yeah, exactly to VLANs. But what is the VLAN? Types of VLANs, how to configure it, what the mechanism, like all about the main core subject we'll discuss on tomorrow. Today, just switch introduction and switch type and switch categories and switch functions like ARP request and ARP reply, manageable switch, unmanageable switch, and switch hierarchy design, access layer switch, distribution layer switch, and core layer switch, L2 and L3 switches, and switch configuration, how to configure it, and how to configure switch ports, speed, and duplex modes. Yeah, exactly. See, the switch 1, 2, 3, 4, 5, 6. Wait, 24 ports. 24 ports are physical ports. Yes, exactly right, obviously. But to minimize the broadcast, to control the network traffic, To manage the traffic, we cannot manage with the physical ports. We can manage with virtual ports, virtual VLANs. Let me explain it clearly about why we call it a VLANs and how to manage it clearly with the physical ports, how we cannot manage it like this. Yeah, Mustafa, full duplex and half duplex, auto. I think we already discussed in the initial classes, right? You remember, guys? We have three type of communication: simplex, half duplex, and full duplex. So half simplex communication means only one-way communication. Half duplex means we can send, we can receive, but simultaneously the same time is not possible. Sending and receiving same time is not possible. Either you can transmit, either you can receive. The full duplex communication, same time we can transmit, we can receive. So if switch port number 2, if your PC is connected and port number 2 is being configured as a half duplex. Now from your computer, either you can transmit the data, either you can receive the data. It's a half duplex. Your port number 2 is being configured as a full. Now from your computer, the same time you can transmit, you can receive also. Instead of a half duplex and full duplex, if you configure as a auto, your PC NIC, your PC NIC card is supporting for what type of communication? The first day, I think so, I have shown you how to check your interface card speed and duplex mode. Network connections, Ethernet adapters, right click on it, properties, IPv4 properties, sorry, configure, advanced, speed and duplex, auto negotiation. But we can use it a 10 Mbps full duplex, 10 Mbps half duplex, like it can be supported. So default option is what? Auto negotiation. So based upon the device auto negotiation, the ports can be supported. Either full duplex, either half duplex, like this. Okay, right. Yeah, no problem. Actually, automation is done is a program actually based upon the programming. So what we'll do generally is a all the scripting like VLANs and DTP, VTP, like all the codes, all whatever configuration, remove configuration, add configuration, the complete scripting is programmed in the one file. So this file will run in one some devices, some application. In the network, you have any issues with a VLAN. The network have any issues with a DTP. The network have any issues with a VTP. The program itself will run automatic some running algorithms. Okay, problem with VTP, they configure it automatically. The problem with the DTP, now generally present we are configuring right VTP or DTP, but what happens in automation? So based upon the any VTP problem, your program itself will run VTP once again. This happen in. programming. So this is a backend which is developed by software engineers. That is a backend actually. Completely programmer. It depends on programmers. Number of active ports in the switch is a collision domain. Entire switch. If 24 port or 48 port, switch is one broadcast domain. The switch have a 1, 2, 3, 4, 5, 6, 24 ports. Out of 24, 1, 2, 3, 4, 5 ports are active. Now collision domains are 5 ports. 5 are collision domains. Number of active ports are number of collision domains. And the whole switch is a broadcast domain, a single broadcast domain. Is switch A, switch B, router 1 and C. This is the connectivity. Port number 8, port number 9, R1 FE0 slash 0, R1 FE0 slash 1, here port number 8, and here port number 8. So my first question is here, in this network topology, how many number of broadcast domains are available? But here switch A is connected to B and switch A is connected to router 1, router is connected to C, right? So in this diagram, how many total number of broadcast domains means what? Exactly. Oh, two broadcast domains. Two broadcast domains. Like have PC1 and switch B PC2. They're trying to communicate. PC1 is a source and PCB is a destination. If this MAC address, if destination MAC address is not in the MAC table, what switch will do? Broadcast. Now broadcast to how many ports? So broadcast to port number 8 via R1 and broadcast to port number 9 to 8 of B and we will broadcast, right? So switch A and switch B will be affected as a broadcast. Now via port number 8 broadcast happening to where? Router also. What router is doing is will stop the broadcast. Router will not do the broadcast. Why no? Why? Because router maintains the routing table. So once topic receive the routing table, what router will do? Will look into routing table. If destination is there, then send what? Unicast. There is no destination drop in the traffic, we don't do the broadcast actually, right? But we have one more very important point, guys, here. If router does not maintain the routing table, routing table is being disabled. Now what happened, you know? So these broadcasts happen to switch C also. Now all devices belongs to one broadcast domain. As long as router is maintaining the routing table, then only it is a router. If routing table is disabled, router also will do broadcast like a switch. So you have to make sure always routing table should be enabled. IP table. Now number of collision broadcast domains are what? Two broadcast domains. Switch A and switch B. Switch A and switch B is one, and C is a another. Two broadcast domains. Number of collision domains. Number of collision domains. So in the switch A, how many ports are active? It depends upon that actually. So here one piece is connected to port number 2, port number 2, port number 8, port number 9. Here three ports. And switch B, here let's say port number 9 and port number 8. Here two ports. Here three ports. So 2 plus 3 plus 2, 5 collision domains here. So always keep in mind collision domains are what? Number of active ports in the switch. Okay, guys. This is all about 1 second. Wait a minute. Right. Just for 5 minutes, let me continue. One more topic, one more command that I will use and continue. Can you hear me, all of you? Yeah. This is my network topology. switch A is the name and this is switch B. And switch A, port number 2, R1 means router 1 is connected. For port number 3, workstation A is connected. For port number 6, FTP server. Port number 4, router 2 we are getting internet access. ISP cable is connected to router 2. And port number 5, workstation B is connected. Port number 24 is connected to switch B. So means port number 24 is a uplink. Uplink port means switch to switch link. Right? So by seeing this diagram only, by seeing this diagram, we can come to know in switch A which port, which device is connected. We can easily understand. What about real time? Log into switch. If you use command show running, now port number 1, port number 2, port number 3, there is nothing. So by login to switch, can you tell me, can you identify which port, which device is connected? So we can identify which device, which port number is connected by seeing the MAC address, right? But how we can tell where FTP server is connected in the switch? Like where workstation A device is connected, where workstation B is connected, where your ISP route is connected, and which port uplink is connected, how we can define that? So to understand the network, so generally in the real time, we'll do what? We'll write some description. Switch. For example, port number 2. Which router is connected? R1, right? So what I'm doing is interface fast Ethernet port number 2 description router 2. Description command is what? Router 2. Exit. Now for port number 3, which device connected actually? The name of device what? Workstation A, right? So interface fast Ethernet port number 3. What is the description? You simply can write workstation A. Exit. Now port number 6 or port number 4. Sorry, let me continue with port number 6. Port number 6, what was the description? FTP server. Right. Exit. Now port number 4. Port number 4 actually router 2 is connected, but router 2 is connected with ISP. So a complete LAN, we are getting internet from which port? Port number 4, right? So what are the description I'm writing is interface fast Ethernet port number 4. Description is internet. Internet port. See, after description command, you can write any names actually. Any message you can write here. Right? And port number 5 is uplink. Port number 5 is workstation B. Port number 24 is uplink. Interface fast Ethernet 5. Description workstation B. Interface fast Ethernet port number 24. What's the description? Port number 24 description is what, guys? Uplink port. Okay. Now any one employee can log into Switch, right? Once any like if you can log into Switch and just log into Switch, if you use the show run command, they can get all the ports information clearly. So by seeing the description, fast Ethernet 0/2. Okay, router 2 is connected, right? Fast Ethernet 0/3, workstation A is connected. For port number 4, okay, we are getting internet port from port 4. Station B is connected. 6 FTP server is connected. And port number 24 is what description was? Okay. So by seeing the description, we can easily understand which port, which one is clear, guys. So this is all about for today. So you do one thing, you design the topology like this and assign the IP address. The switch VLAN 1 is 192.168.1.1. Switch to 192.168.1.2. Make the switch A and switch B in the same network. For PC's IP address, you can use 192.168. 1.3, 4, 5, 6. You can continue for all 7 plus 7 for the device. We design this and tomorrow we'll continue the topic based upon this topology. Clear all of you? So thank you for the session. Have any doubts you can ask me now. Thank you. Thank you so much. Yeah, let me announce one thing for all the participants, and you can get the free study material from the Play Store. You download the Zoom application app. You have videos and free books is there, presentation and even the lab manual is there. So straight away you go to Play Store. Even App Store is also available. You download the Zoom Technologies application. You can get there all those. Present app is working now. The last night I have verified. Yeah, it's working. Thank you once again. See you tomorrow the same. Sunil, for what? What commands you need? Text me in the WhatsApp. I will share you in the WhatsApp. Let me prepare all the commands which is related to the switching to the topic. I'm going to making the commands now. And I'll touch you.